Alright guys, the purpose of today's video is to go over section 8.3, proving triangle similarity by SSS and SAS. This is actually the section that we did right before we were closed. So this is the last section we did Thursday and Friday, but last time I saw you guys. So if you remember it well, then you really don't need to watch this video, but before we take the quiz on Thursday of this week, I wanted to just refresh you guys with what we were talking about in 8.3. So we saw that we are dealing with side similarity. And again, the sides, this isn't the same as back in the first semester when we had the sides congruent. These sides are proportional. So if all the sides are proportional in two triangles, you don't have to know anything about the angles. You can say the triangles are similar by SSS. And our first example of that was example 1 here, using the SSS similarity theorem. Do we have triangle similarity with DEF and GHJ or ABC? And so the solution to that, I'm just going to kind of unveil this. And we want to compare. First, we're going to compare ABC to DEF. So we're going to compare these two triangles. And we take the shortest sides. We take the longest sides and the middle or remaining sides. And since we have the same fraction each time, the ratio of the sides are proportional, and therefore we can say that the triangles are similar. All right, so that leads us to this similarity statement. And then we compare the second set of triangles, ABC with GHJ, but we have an issue here because the sides are all they're not all the same. So we have a 1-to-1 with the shortest and longest, but we have a 6-to-5 ratio with the remaining sides. So therefore, they are not similar. So that's an illustration of using the SSS similarity theorem. The second example, we will be able to find the value of x to make triangles similar. And so in this case, we just want to set a proportion up to solve. So 4 is to 12 as x minus 1 is to 18. So there's your proportion. Cross multiply, and you have 7 as the value of x that would make these two triangles proportional by SSS. Since you do have a third side that has a variable in it, it is a good idea to go ahead and check to make sure when you plug 7 into the value that has an x in it, the side that has an x in it, just make sure you're getting the same proportion. And in this case, indeed you do. The extra example for 2, and again, we want to set a proportion up. So you can say 15 is to 3 as 30 is to x minus 5. Cross multiply. 15 times the quantity of x minus 5 equals 90. Distribute. Okay. And add 75 to both sides. And so then 15 goes in to 165 11 times. So 11, the value of x. And you can double check by plugging it into this side and making sure it stays proportional with 5. And indeed, all the sides do get 5 times bigger. So our scale factor would be 5 to 1. All right. So again, this is a recap of our old lesson. That's why I'm going pretty quickly. Then we also have SAS. We can get sassy with similarity also. But remember, again, the sides are not congruent necessarily. They could be. They could be a 1-to-1 ratio, but most of the time they're not going to be. And they are going to be proportional, however, and not necessarily congruent. The big difference here, of course, is you have the angles being congruent. So the angles will always be congruent. Sides could be proportional. And it has to be the surrounding sides again. You've got to get, I'll do a little similarity swoosh, similar, and so it's the surrounding or the angle that is included between two sides that stays sassy. All right, and example 3. The shelter we are building here, we want to see if these two triangular ends are similar. So we've got the angle pair matching up, so 53, 53. And then you want to check and see if the sides are proportional. And indeed, in this case, they are. 9 is to 6 as 15 is to 10. They each reduce to 3/2 ratio. So yes, we can say the triangles are similar. All right, so there's a sassy example. And our monetary progress, we were checking these two triangles, so this is a good illustration of what you'd be asked to do on a quiz. Explain how to show the indicated triangles are similar. And we've got 3. You got the angles R and N being congruent, and then you know that 24 is to 18 as 28 is to 21. They're each a 4/3 ratio, so yes, you've got sassiness for 3. And then 4, the corresponding side lengths are proportional. So again, just check like we did in example 1, and you have SSS similarity there as well. All right. And our summary, you got 3 ways to make triangles similar. You've got AA similarity, you've got SSS, and you've got sassy. All right, guys, quick review of section 8.3. Hope you enjoyed it. And again, you can watch this as a review for Thursday's quiz.